Okay, so we request that you make sure to like mute your mics so like the professional has like your undivided attention. And yeah, we thank you for that. So PHS is an international student-led, women-led, minority-led nonprofit to essentially advance like for medical advancement. It's to help prospective healthcare professionals gain like access to like educational resources, no matter what demographic status they have or abilities or their location. My name is Mahesh, and I'm one of the live session volunteers at PHS. Thank you guys for attending today, and yeah, let's get started. There's some people in the waiting room. Okay. Just a little announcement. We do have, I believe we enabled closed captioning for the video just to accommodate all students in case like you want to go back and see something that our professional said today, or if someone's talking too fast, you just want to go back, double check. We have that available for you. And if you have any questions about what happens in the session, you can email us at info@prehealthshadowing.com, or you could email the professional. I'm pretty sure he has his email in his presentation. And if you want to stay in the loop, you could follow our social media. We have Instagram and then TikTok. And then so as like an international organization, we host students from like all over the world. We're not just trying to be confined to the US. We're trying to like spread our wings, help healthcare professionals all over the world. So if you'd like, you can just drop in the chat, where are you tuning in from?
So many places.
Yeah. Okay, I see New York, Arizona, Texas, California, Chicago, Oklahoma, more California, 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 California. Oh my God. So I see that. Okay, so if you guys are interested in being a part of pre-health shadowing, we have a lot of amazing opportunities for you to like take part in, and then there's a lot of benefits of being part of our program. So if you really want to play a bigger role in supporting PHS, we have like a big network of student volunteers that we are and team members that we would love you to be part of. So you can be part of our administrative team that's like leads of outreach, marketing, live sessions. We have a PR team for a book. And then there's a lot of various projects you could and initiatives you can be part of with like professional outreach, grant writing, and the volunteer teams, etc. And if you're a high school student, we're especially looking for you because you guys are essentially the future of medicine in our country, in the world. So we want you to get involved. We have a program called the High School Training Program for PHS, which allows you to connect with pre-health programs across the country and the world, and it helps you get involved in fundraising for PHS and organize resources for other high school students. Okay. So yeah, so these are all the leadership roles that are available. Like I mentioned earlier, if you want, you could just take a screenshot of this. There's the link at the bottom too. You can apply for them as well. So if you want, we like really humbly ask that you can donate to our program. We completely run on donations. We're a nonprofit organization. We're student run, and we work around the clock to keep this program free and accessible for everyone. Unfortunately, Zoom is not entirely free, so any contributions you can donate to our website would be greatly appreciated. So yeah, we'll have like a few links throughout the session for that. And while you're taking the certification quiz at the end, there's an option if you donate, if you are able to, please. We would greatly appreciate if you could do that. And we'd also love if you could have your camera on, so it's more of an interactive experience. But if you're not able to, that's okay as well. And yeah, I think without further ado, I have great appreciation for Dr. Jiwang Chen. Thank you so much for joining us today. If you can share your screen whenever you're able to, that'd be perfect.
Okay, so let me share. It's clear. Can you see my window screen?
No, I don't think we can.
You not see my PowerPoint slides? I think you might.
I think, oh, okay. Perfect.
Or maybe I stop sharing and retry once again. Maybe you have the slides over there.
Yeah. Oh, okay. I think everyone else can see, so I think it should be
Can
fine.
you see it? So everyone see. Okay. So maybe I start.
Yeah.
Okay. Good evening, everyone. And really, it's my great pleasure to present a seminar here. In fact, my title is Building a Successful Career and Exploring the Powerful Medical Echo Imaging. So, my talk, in fact, is included two parts. And first, I talk about my career journey, and according to Mike, I provide some suggestions on our career development. And the second part, I talk about my major expertise, and do the preclinical echo images. Maybe it's beneficial to some students who are interested in the clinical research on health science. So, it's first part is it's according to my years experience. I would like to give some suggestions on career development. And I get my PhD, in fact, in Oklahoma State University in Stillwater. That place, Stillwater is they try to that. I was called try to dig oil. There always water, so that's called still water. I have really have a lot of good time in still water. And after get my PhD, then I start my postdoctoral fellowship in the OSU, and then I came to Northwestern University Medical School, Pharmaco Medical School, started my postdoc. And then I started my research faculty position at Northwestern, and then later at the UIC, University of Illinois Chicago, and my current university. And currently, my job title is I'm the UIC Cardiovascular Research Core Director, and my major research focus is study the cardiovascular and pulmonary disease. And what I have done so far, in fact, I accomplished like over 5,000 rodent right ventricular systolic pressure. In fact, how to measure this right ventricular systolic pressure? In fact, using the catheter and through and the right that's external jugular to the right ventricular to measure the right ventricular systolic pressure. And normally for mouse is a little technical challenge. At the beginning, in fact, one day I cannot get any success, but later I almost 100% success for this procedure. And also, I accomplished like over 6,000 like rodent mouse rat echo images. And so that's in fact I published close to 90, 100 peer-reviewed papers. I mentored over 50 students, fellows, and many of them are, become physician or at the medical school or become, dentist or pharmacist in the hospital. And I'm so proud of them. And also as a core director, we support numerous grants for UIC principal investigators. So in fact, through these years' experience, what I learned, in fact, so far, and for the surgical skills or the imaging, the preclinical imaging, in fact, I always believe that 50 practice definitely better than 10 practice, and 100 practice better than 50 practice, and 1,000 practice more than 100 practice. When you do the over 1,000 practice, you maybe become expert because you feel more confident that. Of course, I think everyone knows that hard work is very important. In my career, I always currently I always first one to the lab and the last one to leave. I think hard work definitely very important, and also be passionate. Because we live in this world, we need to do something for the community. I think I maybe give you two stories, my personal experience. I think last year, I think when in the one winter, and when I come out from the gym, and I saw, one person maybe unintentionally and not intentionally, and leaves one box of the nail on the driveway. And when I see it, of course, I immediately go to my office and I spend almost 30 minutes to and remove clean all the nails, if a nail still there, I think the many cars maybe get a flat tire, and if I not do it, many, I think, I feel very guilty, I cannot sleep. So, and also another things, in fact, I think also last year, and when it's a big rain outside, and our university's one elevator is big leaky, a lot of flooding over there. And I immediately called the UIC police officer. So they really come here and they fix the elevator. I think save the university like I think $2,000. I feel that this I should do it because I'm the university's faculty. I should, if I see it, definitely do it. And I just why need to see this one. If we are physician, and if we see the patient and almost die, if we can do something, definitely we need to do something. We cannot be so cold. I think. And also, according to my experience, also be eager to learn new things, no matter how old you are, and be eager to ask questions. And I remember years ago, a Harvard professor come to UIC, deliver a talk, and he asked the questions like which kind of cells is good for the study the aging, because he studied aging. And many professors, and some professors, endothelial cells very important. Some professors said macrophage. I clearly stand out. I point out the red blood cells is maybe very important to study aging. Because the red blood cells have the very important for the innate immunity. And because red blood cells service have the Duffy antigen receptor. And Duffy, in fact, is patients in the African. And people, I think in 1954, and the physician found one patient, that's called Duffy, and found he drinks the water with malaria parasite, and he's okay. And then the doctor study, his red blood cell and found his red blood cell is selective for this Duffy antigen receptor. This receptor is for malaria parasite, and later scientists found this antigen receptor, in fact, also for cytokine chemicals. And when our body has a pathogens invasion like virus or bacteria, so invade to our body. In fact, this red blood cell will release the cytokine chemical. So that's why we have the once we have the this viral infection, we also have fever because these red blood cells release this cytokine chemical. This cytokine chemical will kill this the virus, of course. So this, I feel that, that time I point out this point, and that professor very, of course, agree my point. I think a few years later, he published later in the, I think he really using red blood cells. I'm not sure he, consider my, questions, my ideas important, but I feel the ask questions is very important, If the speaker give lectures and no question, I feel that maybe no interest, I say, So try to eager to ask questions, I think no matter, I think that's very good, And also we need to well manage our emotion, Sometimes, emotion, angry does not work, We need to well control, manage our emotion. That's according to my years, what I learned, I would like to share with you. And yeah, as a core director and also the mentor, what I care about our core staff. In fact, of course, the staff's expertise, and their productivity, and that's of course number one important. And also I care, and their staff, they enjoy their work, This is very important, And also be responsible, be responsible. And also I wish, the staff a desire to learn and grow, and also can get along well with the peoples and around. So I think this how I care about our staff. And I also show this slides to this one professor, Henry Rosevitsky, is a professor from the Harvard, and he pointed out the goals of the liberty education. He pointed out that all educated person, in fact, must be able to think and write clearly and effectively. That's communication and no any problem. And also, the educated person should be achieve depth in some field of knowledge. Now you have some expertise, and for living, also of course for work, and also have like a critical operation of the ways in which we gain knowledge and understanding. Means critical reasoning, have clear logic. I think that's also is very important for educated person. And also, the educated person needs to understanding other cultures and other times in different period and different period of time. And also, is educated person must have some understanding of experience, think about moral and ethics questions. So this, I feel this maybe important, for, if we we are the educated person. I feel that this is very important. Yeah. And also is let me see, click this one. And also, according to my years working experience, I would like to provide a suggestion for having a successful career according to my work experience. At first, I think have a strong interest in what you are doing and you will do. So this, of course, very important. And also set up the clear goals and dedicated, to working hard towards this goal. And of course, we need to be aware of ourselves and the potential and resources, so they try to take advantage and the potential resources and where can the challenges and failure in our life. Failure, in fact, mostly is a mark of the success. And also be honest, to win the trust. Honest, very important, when we communicate with someone else. And get aware along with the people around and win the support from our mentors and colleagues. And of course, have great communication skills. And I think that's normally, that's for successful career. And keep learning our whole life and also stay healthy. Once you have and try to work out regularly. I think it is physically is healthy, and also I think it is very important for the mentally healthy. That's my understanding. Yeah. So hopefully this is my personal experience and suggestions. And for high school and undergraduate students, I have some this suggests. Of course, we need to improve for high school students, and we need to improve our writing and oral communication because this, of course, is very important. And of course, the GPA is crucial for our next step because the GPA, of course, people have not meet before you meet, they of course see how your ability, learning ability. GPA is good, is a very important career. And also be eager to learn cross the field, explore and find your passion. And learn some computer. I think that in the future, AI become more and more important. So learn some computer science and AI fundamentals. I think they are shaping our future. Maybe we need to had better learn some basic, computer science knowledge. And thinking long term and plan our career path according to our strengths and the resources. And of course, working hard and be provocative, active, and take ownership of our learning and build good relationship with peers, mentors, and professors. Yeah, and repeat once again, stay active. Regularly work out once you feel tired, work out and keep our body and mind strong. I think this is also important for for high school undergraduates. I hope this helpful. So I also cite the Elon Musk that's advice. He mentioned that consistently think about how we could be doing things better and question ourselves. We need to challenge ourselves daily and apply this in science and life. I feel that this is very helpful. So for me, I always put in my that's my core and I always see it. And so that's one piece of advice I would like to from the Elon Musk to share with you. So that's my career journey, and I give you some suggestions for my career path. And the second part, I would like to talk about applications of the preclinical echo images. So that's my expertise here. And I started to do the echo preclinical echo started 2016. As I mentioned, I also do more than 6,000 the rodent echo images. So I would like to share my learning experience with you. So echo, in fact, is a sound that's repeated because the sound waves are reflected back. So echo means, like reflect sound waves. So when we see mountains, deep mountains, when we speak something, so we always see the echo come back. So that is the definition of the basic the echo physical phenomena. And there are three steps for the to create echo images. First, the create parsed ultrasound waves. So the echo machine they have the piezoelectric crystals in the probe, and this probe once collect the electricity, and so this crystal will vibrate and emit this a certain this that's a wavelength, and so then and also this crystal also can absorb this echo. So the detection that's echo, and then this echo machine will format of images based on the time elapses between the emission and return. So that's how the three steps to get to the echo images. And I give example to show how how the echo machine makes the images. So the transducer, as I mentioned, they have the special crystals that emit that's the sound wave, and so the reflect off the soft tissue like heart. So this is the top part. In fact, that is right ventricular, so that's left ventricular, left atrium. So this, according to, that's three steps. So the echo machine can see their, according to their time elapse between the emission and the return. So they can build the special the images according to the different location. So that's like so that's the right side. That's we can see the the echo images from the real the soft that's hard tissues. Yeah. And in fact, our capacity, we have two different echo machine from the Virasonic, and one is the Web 2100. And another one recently, last year, in fact, we get Web 2. I think this may be the best, the echo machine, the dominant in the world, world. And so this echo machine is we can get the 4D images, and we have different transducers, the probe, and emit different wavelengths. And so we have from the we can images zebrafish to the large animal, including human and the swine. So this is our human heart autonomy, like our human heart, can beat about 100,000 times per day and pumping over 2,000 gallons of blood through the body. And this images is typical that's human heart. And the human heart including the four chambers. One is like right atrium, left atrium, and right ventricular and left ventricular. So the blood, in fact, through the superior vena cava, and goes through this right atrium, then goes through the tricuspid valve and go to right ventricular, and right ventricular then goes through the pulmonary artery. So the blood pump through the pulmonary artery, then go to the lung. So lung gets the gas exchange, through the type 1 alveolar epithelial cells, and so the CO2 will be released and absorbs, oxygen. So oxygen, the blood will go through the pulmonary vein, then go to the left ventricular, and those then go through aorta and go to whole body. So they provide oxygen and nutrients for our different organs. So that is is human heart anatomy, And I would like to show you that's, I think this one may be blocked, hopefully. No, no, okay. So this is some echo mouse heart echo images I take, I share with you. So this is left is left ventricular, that's long peristernal, long X view. So we can clearly see this is left ventricular connected with this is the aorta. And the top part, of course, this right ventricular pulmonary connected the pulmonary artery. So the right part is the left ventricular short X views. Through this LV as long as short X, we can measure the left ventricular systolic function and then like ejection fraction, fractionating cardiac output, and also we can measure the left ventricular like wall thickness and diameter volume and the stroke volume as well. And so let me see another one. Another one. So this is the mouse heart that's apical for images. So let me see this normal mouse heart. You see, this is this four chambers. So this left ventricular and connected the left atrium. So this is a septum here, and the right ventricular connect the right atrium. So this tricuspid here. So this normal is a mouse lung. And this right side is in fact this heart in fact also apical fourth chamber. And we can see the left ventricular connect the left atrium. And this right ventricular is much bigger than the normal as a mouse RV. So this typical, the RV become larger. And in fact, their RV free seat become thicker. So this typical, this mouse close to die because, the gas exchange cannot efficiently pump blood through the pulmonary artery to the lung. So gas exchange cannot be like efficient done. So normally, and in fact, in our country, this right, pulmonary hypertension patient normally have right heart failure. So that's blue. In fact, that blood very kind of blue. So they also called blue lipo disease because the blood cannot be cannot reoxygen, exchange, the gas exchange cannot be efficient done. So in fact, the echo is so important and to test whether are we heart failure. So let me show you another one. So this one is the pulmonary artery. So this right ventricular connected the pulmonary artery. So this we can see the valve here. So blood goes through the RV, then goes through the pulmonary artery, then go to the lung for the gas exchange. So in fact, this echo machine can do this, measure the pulmonary artery that the blood flow. So we can measure the pulmonary artery acceleration time. So in fact, this mouse have pulmonary hypertension. So the PAT, in fact, pulmonary acceleration time, in fact, very small compared to. In fact, I should show the normal mouse, the pulmonary artery that's positive images. So this one is very, physician use this data to evaluate patients whether have the, the pulmonary artery, the blood flow whether normal or not. Of course, to evaluate the pulmonary, diagnose the pulmonary hypertension, that's the disease. Also, the physician also using the like RV fever thickness and the cardiac output. And also, like taps, that's see how the tricuspid movement. So this all, and combine together and for the patient's diagnosis. And yeah. And so then in fact, I also, in fact, UIC, I think I'm the first one to develop the mouse coronary artery blood flow using this our echo machine. So this typically that's coronary artery blood flow. And so of course coronary artery blood artery in fact provide the nutrients for the heart. So this the bottom part is typical, like and the coronary artery, the systolic diastolic wavelengths. So we can using this echo machine can detect coronary artery disease. And so far, I do not have some disease, coronary artery blood flow, but normally we can measure the CFR, then to measure the coronary artery disease. And so infrared echo also can detect hypertension. And because hypertensive patients, normally their left ventricular wall much thicker compared to normal patients. So in fact, this is a healthy mouse that's left ventricular M mode, mobility mode, and we can see their left ventricular the wall thickness like this way. But in the right part, and so this mouse have hypertensive. Uh, so this you see the left ventricular the wall much thicker compared to normal. That's healthy mouse. So this also is a very good, that's parameters for us evaluate this whether this mouse have the hypertensive or not. And echo image also can detect the tumors. So this left side is breast cancer. We can clearly see the tumor, breast tumor here, and right side is in fact liver. So the echo machine can can detect the different that's liver tumors and also can measure the liver tumor size and volume. So this in fact F2 can do this work. And I showed one more image. This one for our customers. So the normal liver, like very almost nothing here, and but the mouse in the liver have the tumor. You see that clearly. The tumor we can clearly see under the and that's the echo machine. So very robust for the tumor detection. And scientists, in fact, also in fact create the mouse bladder cancer model. So they inject the cancer cells through to the bladder. So they then detect the cancer tumor growth in the day 7, day 13, day 19, 25. The tumor grows and bigger. So how to detect echo machine can clearly see the tumor size and so that's in fact very important for physician cardiologist for physician how to the treatment beneficial the treat the tumors. So the echo also can detect lung edema. Edema, in fact, lung edema means too much fluid in the lung. So normal healthy lung, mouse lung like A line. So this normal a lot of air inside. So the gas exchange very normally can be done. But if some mouse lung with edema, like if you have like pneumonia or either viral pneumonia or the bacterial pneumonia. So they have edema, they have B line here, those smeared. So that's in fact is clearly show that this mouse have the edema. Yeah. And also echo can detect the embryo defect. So this is three embryos here, and the first and third one is normal embryos, but the middle one, in fact, this embryo is dead. So echo really can do for the babies, embryos detection, whether it's normal and abnormal. And also echo also can detect started kidney function. So this one, in fact, I did at UIC to study 6 disease mice. And we inject a contrast called a microbubble contrast through the tailwind. And so then within short time, and so this so then this is kidney, mouse kidney. And so then we can, measure the signals, and we measure this in the time to the saturated time when this microbubble contrast, this signal becomes saturated. This time very important. If time shorter, so that means that's kidney perfusion faster and blood flow is of course faster. Yeah. So in fact, this is very important to study sickle disease and also evaluate the kidney function. And also echo also can measure the artery stiffness. So as we know like when the people become older, so the our artery will become stiffer. So the artery stiffness in fact is a very good marker starting aging. So a few years ago in our team in fact published using the echo machine and using the ApoE lockout mice with high-fat diet. So this is typical atherosclerosis model, and we measure the aorta arch and carotid artery stiffness. So how we do it? So we get the aorta. So this is typical ascending aorta and then descending aorta. So we measure the distance. Select one fragment from aorta, ascending to descending aorta, and distance, and also measure the time. So this distance divides the time in velocity. So this velocity, in fact, scientists using it as a to in fact very corresponding to their aorta arch stiffness. So let me see. So we, so in our paper, we how we measure the distance and how we measure the time correct form. We can measure the time. So in fact, we can see the normal diet and with high-fat diet. So that's mice with atherosclerosis. So we clearly see that the aorta arch, that the blood flow, the venous pulmonary PW velocity, in fact, significantly higher than the normal diet. So that's aorta arch stiffer in the high-fat diet mice. So this one really, of course, very useful, to study aging and also other like atherosclerosis, as I mentioned just now. So the echo also can, and I also can study the zebrafish, a very tiny zebrafish echo cardiography. So zebrafish is a model species to study cardiovascular disease model species. And in fact, the zebrafish heart very simple. They only have one ventricle, one atrium, and also have something called a bilateral arteriosus. And so this is I from the Wikipedia. I see this how this zebrafish the heart, and in fact the heart close the gears. So I'm the first one, in fact, develop this zebrafish echocardiography in our campus. So this is this is typically the zebrafish that's the heart. This blood flow is ventricular, atrium, and this bubblers, that's side structures. So this one we also can do the color Doppler, see how the blood flow transferred from the between the ventricular atrium. And so this one, in fact, we have one customer using this technique and published, in fact, Nature Communication papers last year. And in fact, we provide technique. I'm so happy, to provide this technique. Yeah. And I think so. That's tonight's my talk. And I, in fact, first I share my career journey, and in fact, my career really driven by curiosity and passion. And I'm really interested in science, and so I never feel tired, to be honest. And also the second part, I present the preclinical echo images. In fact, very useful, powerful to study medicine. And finally, I encourage you, I would like to share the fun tips with you, and especially for high school students and undergraduate students. Try to stay curious and be passionate and keep learning and believe in our ability to make differences. Yeah. And I think that's my talk. And now I would like to take questions.
Okay, if you guys have any questions for the speaker, I think this is a good time to do it.
Chat, let me see chat. Oh, some. Any questions in terms of career development or the clinical, the preclinical echo images? Just feel free to ask me, or or you can
Yeah.
Google find my email address. You can email me. I try my best to answer your questions.
We have a question in the chat. How does an echo
Okay.
machine, use sound and then convert it to something we can see?
Oh, so in fact, I have one slide that shows that in fact that crystal in fact contained that in the probe. In fact, once connect electricity, so this crystal will vibrate and then emit the sound wave. So in fact, of course, a different crystal will emit different wavelengths of the sound wave. And this crystal also can absorb once emit this sound wave. So of course, so that will have echo, reflect sound wave. So that these crystals also can absorb and this echo, this sound wave, and then according to this time elapse, between the emission and return at a different location, and then the echo machine will formulate the echo image. There's three steps in one slide. So I showed that one. Yeah, thank you for that questions. So let me see. Did you always know you want to go into medical related field? Yeah, so let me answer these questions, And in fact, want to go to medical related field. In fact, I feel that, my career path, in fact, I'm not given, in fact, my PhD, in fact, is plant science, is not in the medical research. But later, I think for some reasons, of course, my major reason, my interest, and I migrated to the medical research in Oklahoma State University veterinary medicine, and I studied the lung disease and later, I found that I become more and more interested in medical research. So then I come to Northwestern Medical School and continue in the pulmonary research. So I feel that I really interested in medical. I feel that I really can do something for the community, for the community, not only like train the scientists, I mentioned that many undergraduate students work with me, and they want to become physician, and also I trained like a scientist, benchwork scientist, and train them how to do the echo, how to do the measure, how to do the hemodynamic measurement in the animals. And I feel that they become more and more, very useful. I feel that I'm very important, kind of for the community. I feel that I have really do something for the community, and I feel that I'm really interested in medical research. Yeah, so that's my understanding. Yeah. There another question. You suggest to get some AI, computer science experience because it's become more relevant in medicine. As an undergraduate student, how should I go about doing this? Thank you for that question. In fact, last year I really recruited two smart high school students from the Chicago, two different high schools, and we work in the project and how to using AI and and analyze the patient's clinical echo data. and really work. In fact, for us, normally 30 minutes and to analyze one patient's data. But for the AI, like 4 minutes, and we can, input image, then immediately come out. So I think that's very strong. And I think this run is still early stage right now, and is pushing like for the rodent, for the animal preclinical echo images right now only in the Pfizer, and one scientist. Duan, in fact, Dr. Duan, in fact, from Pfizer company can do this work. I feel that to answer your question directly, I think it's if you are, I think try to learn some computer science courses, how the program, I think of course, some website maybe directly I think some company definitely develop some information, some softwares and how for us to learn. But my point is that as an undergraduate, maybe we need to learn some at least some computer that language. To learn, to understand, and in the future maybe you can contribute to something like how to use AI to. So that's my personal understanding. And I think maybe I think this summer we continue this work with these high school students and try to publish our papers. In fact, we do have one review paper how to use AI analyze clinical images. So I think once we have papers, maybe you can read it, and use go through the PubMed. I think of course, if you go to PubMed, you also find many papers. How to AI using the tool for the clinical image analysis. So that's my personal suggestions. Yeah. So other question: what specific echocardiographic parameters image tech are most effective for diagnose and monitor right ventricular failure rodent model compared to human patient? How do they measure count for the anatomic and physiology? Yeah, this I'm very familiar. Yeah, thank you. This question is a very good question. And I published one paper 2019 in the Pulmonary Circulation. And if you Google my name 2019 pulmonary circulation, and in fact in general there are several parameters. One is the pulmonary acceleration time, and RV flavor thickness, and the taps, and also the right ventricular, that's a fraction area change, but that parameter not important. I think the key is pulmonary acceleration time, RV flavor thickness, and the taps. So that's typically, and in patients and in the animals, it's a very good parameters for diagnostics right ventricular hypertrophy. But of course, golden that's the standard. Still is hemodynamic measurement. So using the transducers through the external jagged vein to the right ventricular, measure the right ventricular systolic pressure, or measure the PAP, pulmonary artery pressure. So the gold standard for pulmonary hypertension still like a PAP over 20 millicurie, something like a definition. That's clear definition in the clinical part. Yeah, hopefully I answer your question. The next question, how did you come up with your research question? What was your inspiration to use echo, especially in your research? Of course, because I'm the cardiovascular research core director, we are co-facility, and we provide service for our customers. And before provide service, we need to be expert. We need to be very familiar, and this echo images. So at UIC, I trained, I think almost 100% people who do echo. I train them how to do echo, and at the beginning, I think, because I mentioned that I'm the plant science major, PhD, in fact, also PhD. I'm not in this field at all. And but 2016, I started trained by the company expert, who study of course, the echo images. I learned from him, And at the beginning, I do not know how to do, how to do very well. But I really spent a lot of weekends, a lot of extra time practice. I mentioned that I practiced over 6,000 mouse echo, and I published the papers. I already published echo data in like pulmonary circulation and Nature Communication, Science Translation Medicine, and JCI. And so really, through this publish these papers and make me, and learn a lot. And so that's in fact, of course, when the community requests to some like coronary arteries echo imaging, that's very tough, especially in mice. And but when you try it, and see where it is. Normally, when you see the pulmonary artery, then the aorta between, then you will see that's coronary artery. And so when you work out something like I present microbubble contrast enhanced ultrasound. So at the beginning, I don't know, in fact, and also artery stiffness. I don't know how to measure the time, how to measure this, distance. I don't know at all, But when you follow the online videos, something and learn from the colleague, and then and at the beginning maybe you're not feared, but then when you do more, then more success, and when you do thousand, then you almost 100% successful. Yeah. So that is hopefully answer your questions. Yeah. And of course, I also do research as well, and so always do some, and research service R&D, develop new service. Of course, from the market, the PI. I always talk with different professors and ask them what they are interested in and what they lead. And of course, as a core service director, and their request is our service R&D. So that's in fact the questions come from. And you mentioned that you use the microbubbles assay to assess quality of renal perfusion. Have you used this to study coronary artery blood compared to Doppler studies? I haven't used this one. I haven't. And normally microbubbles not, but of course the microbubbles can deliver the drug, and people can conjugate their drug to with this microbubbles powder, then treat this maybe treat this coronary vascular disease. Yeah. So yeah, next question. For students looking to become a physician, what are some of the benefits of the having experience in preclinical research? Yeah, I feel this, and thank you. I mentored so many high school students and so many, undergrad students, and I feel that I think I feel maybe you try to work with some scientists and write review papers. I feel that review papers is good learning in fact. And I like my high school students, undergrad write papers, review paper. Like recently, we just published papers like vascular aging. And also how this high salt affect cardiovascular disease. How this red meat affect cardiovascular disease. And how this plastic, that's not good for our health, something like that. So I encourage the high school students and undergrad students to write review papers, create a solid evidence, demonstrate your excellence, because these publications will beneficial. Write good way to write your, of course, and you can ask your mentor to write letter of support. And I think it's you can write in your CV, but also when you work with your mentors, you can prepare a poster, present in the community, some conferences. These also can be write to your CV. That's my understanding. Yeah, hopefully useful. As a incoming sophomore in high school, what do you recommend I should be doing to better expose myself in the medical field? I think for the sophomore, I think you still have some time, before your ACT exam. I feel that I think summertime you can visit some, like research lab, shared with some physicians, see how, see whether you are really interested or not. I feel that I think that's number one interest. Interest is very important. If you are not interested in, I don't think you continue, move forward. I think, so that's, share with some physicians and, visit some lab, tour some lab and see how they're doing. I think even maybe a few times, maybe helpful. In fact, our core really like we accept like like this year like received 5 high school students. They work with me, and like write review papers. I give them tour about our core and give them tour to visit like a robot lab, how the AI, how robot do the surgery. Because we have the AI, robot lab, for so that's in fact some high school are very exciting. I feel that it's maybe beneficial to force their interest. I think. So next question: how can undergraduate students stand out when applied to medical school? Undergrad students, I feel that of course your GPA should be very good, and because the medical school very competitive, and also you have research experience, some research experience, some like you have shadow with some hospital physicians, shadow experience beneficial, I think, and in fact I have several, I have one student, in fact, he just got a medical school in fact, this fall. And when he works with me, in fact, he came to United very late and from Dubai. And his, SAT score, no, MCAP score not good, 503, I think, not that good. But he worked with me for more than 3 years. And I encourage him. Of course, he has a poster with me. He has a paper with me, and he has a bunch of poster award. And then, in fact, he shadow with hospitals and shadow see how they collect blood. And then later, he can collect the blood from the for patient. And recently, I asked how many patients. He collected. He said over 2,000. You see how this. Of course, when he get several offers from the from the different medical university, I feel that he really interested. He always asks me question, and of course I bridge him with some physicians, shadow with some pulmonary physicians, and so I feel that very helpful. I feel. And so that hopefully answer your questions. Yeah, stand out when applying medical school. Yeah, GPA, get shadow experience, get the research experience. I feel that that's very important. So then thank you, Dr. Chen. I'm a undergraduate explore healthcare, especially. Oh, great. Do you happen to have any connection or suggestion or shadow opportunity? Um, I'm not, but I think you can directly email with some doctors in this field. I think always he say I'm very passionate in this field. Can you provide some shadow experience? I think normally some people really reply you. I say I cannot, I do not have, but I do I do many do the cardiovascular and the pulmonary research. So the next question, how can high school students initiate small scale research in healthcare or mental health field, given that typically lack formal training or clinical experience? Yeah, that is very tough. I think that's very tough. My understanding in small scale, maybe I think try to connect, reach out some professors, or especially physician scientists, and so maybe ask them. Maybe they can provide you some help, some opportunities. Yeah, I think. and try to, brave to reach out to this physician scientist. I think physician scientist is very important. I feared maybe good, they may have do some small clinical trial, and maybe let you join, I think, but normally is a little tough, I think. Normally high school students, and I recruit high school students, of course, I never do the sacrifice animal in front of them. I always let them, I give them some scientific questions, and I I just give you example, like why some, the medical school logo always have snake. Why is the Japanese people's life expectancy longer than in other countries? Why is it live longer? And something basic questions. And later, these people, these students, I let them to generate PowerPoint slides and show their answers. They are very interesting. In fact, and after one summer, they prepared a bunch of PowerPoint slides to answer these scientific questions. And also because I don't have time. Normally I have 30 minutes with our high school students each and talk with them, and try to foster their interest in medical research. So they are real many of them, they are really become more and more interested. I feel very happy, And then I'm that questions. Thank you, friend. Oh, thank you. As a pre-med, uh, as a pre-med interested in cardiology, thoracic surgery, do you have any advice for research, any special topic I should focus on research? I think, let me give you an example. I have one student, right now he's a dentist, and he works with me for several years. Of course, he has a first author paper, something like that. And he's a dentist, and he really spent 1 year practice mouse using mouse and teeth, practice his skills. And I think that is very useful. I feel that if you want to in the future focus on I think cardiothoracic surgery, I feel that once is that maybe try to find a lab like our core, and do animal surgery. I think that another one maybe shadow with some cardiosurgery physician, doctors, surgeon, and they maybe let you observe. I know in Northwestern, and one physician in fact do the lung transplant, and he always ask the undergrad students shadow stand beside and draw some pictures, and so that is also good opportunity, I think. So I also encourage my students to share with look for opportunities in the local hospital during the summer. And one student is really successful. She told me, she just in fact later he get paid, in fact, and for the local hospital, there are some surgeons, like shadow. I feel that you can try to reach out to some local hospital surgeons. Maybe they can help you. And that's my suggestion. Yeah. Thank you so much for your presentation. Very interesting research. My question is, how do you develop a new research paper idea? Do you have the process? Yeah, I do have. I think when I read, read some news, and especially I mentioned the one story. Several years ago, maybe 10 years ago, I mentored high school students write a review paper called "Why the red meat not good for the cardiovascular health." And in fact, how I get an idea. In fact, I read one news shows that why is it European country like Italy and France, their people, in fact, cardiovascular disease much lower than other countries because they eat some, of course not red meat, but they have this because they have eat a lot of what's that tomato, then in fact that one in fact very helpful. And also the red wine, that kind of they have special component, respiratory, in fact beneficial, the cardiovascular health. And then later that originally, if you read our paper, if you look for my name and say the red meat and how the beneficial the cardiovascular disease. And in introduction part, in fact, what I tell you, why the Italy people have less cardiovascular disease. In fact, that is because they drink a lot of red wine, or normally compared to other countries, because the red wine contains a special that's component in beneficial the cardiovascular disease. So that induction part, of course, catches the eyes. So that is how, and of course, my research, my current research, of course, for funding issue, like to develop, recently, my focus treats the stroke, because stroke is a large population in the world, for the deaths in the world, So in fact, I try to develop some drug and treat the stroke. In fact, in fact, I really found one drug. I feel so happy right now and still testing, doing peptide, and AV virus, and full target one gene, and also, of course, how to get idea. I think I always attend a seminar and always ask questions, and when because I always thinking the two has better than one. When we because when a speaker always have some expertise. They present their whole life research. Of course, they always present some interesting topic, and I always get the idea, how to from this attend the seminars. Yeah, so that's my understanding. Of course, I encourage you to read the papers, read the news, see whether you can do something for the patient, for the disease treatment. I think so that's we need to passionate in science, medical science. Yeah, hopefully that answer your questions. Yeah. I think that's answered all questions. Yeah. Okay. So no more questions. If you have more questions, you can email me, and my email. In fact, you can Google my name, and then you will find my email address. And I try my best to answer your question. Yeah.
Okay, thanks so much, Dr. Chen. That was a really informative presentation. I'm really happy with the student turnout today. There were a lot of students. You guys asked some really amazing questions.
Thank you.
We have like a finishing presentation. Let me just share that real quick. So we would encourage you guys to reflect on the session today. There's three things we want you to think about. One, what brought you to this session today? Two, what are some major takeaways you got from Dr. Chen's presentation? And three, what would you want to learn more about cardiovascular health? And like Dr. Chen said, like you could just look him up, email him, and I'm pretty sure he'll get back to you really soon. So you don't have to write it down, but it's encouraged that you do, and you can submit your thoughts and today's session here. Okay, so it's not required, but we encourage you to do so. It's gonna be published on our website, and it looks good on applications as well.
Oh.
So again, if you're interested on being a part of pre-health shadowing, we have team member applications, student volunteer applications as well. So we like we went over in the beginning, there's like heads of outreach, marketing, and live sessions, PR teams for a book. Whatever you could possibly find about healthcare, we have it here at PHS, and you can be a team member or you could apply to be the head of a certain department that we need head for. And again, we humbly ask that if you can donate to our organization, we can say please send if possible, you can send a few dollars to through PayPal or Venmo. It costs a lot to keep the program up and running and free for everyone. So if you're financially able to donate, please help those who can't. We encourage you to donate to our organization. Any donations are appreciated because we run solely off the time and donations of volunteers. So thank you again for that. And now the part everyone's waiting for, the digital certificate for attending. So you can visit our professionals course page at phs.prehealthshadowing.com, and you can sign up for the free course under live sessions. And then if you like weren't able to attend the session, or if you just wanted to recap over something, there's a like YouTube video of the live recording that I've been doing this entire time. You can go over that and then do the simple 10-question quiz based on what the presentation is. You have 2 chances, and you have to get a 70 or above to get your virtual shadowing certificate. And quizzes are open indefinitely for your convenience. Like you could do it next week if you wanted, just like revise your notes, anything like that. And if you missed any part of the session, you can go to Pre-Health Shadowing's YouTube and just see all the previous sessions and today's session. And it's all completely free. So you can subscribe to our so you can just stay in the loop, essentially follow our Instagram, TikTok. You'll know when like our presentations are happening, and then make sure to join them every week if you're really passionate about medicine like that, or just if you want to learn more about medicine. And see you next time. Thanks so much for joining. If you have any questions, feel free to stick around and ask me, the student team, or Dr. Chen. Thank you.
Bye-bye.
Thank you, Dr. Chen.
You're welcome. Good luck.
Thank you, Dr. Chen.